This video is going to cover how to calculate the volume of gas produced using simple ratios and ratios which involve an excess. So if we take the simple ratio first, it says what volume of CO2 is produced if 100 cubic centimetres of oxygen is used to completely burn some CH4 gas. So the equation is given. If it isn't, you will have to write a balanced equation. It also notes that this is performed at 50 degrees Celsius. So first of all, you have to compare the ratio from the equation of all of the gases. So if we take CH4 as 1, if 2O2 is 2, CO2 is 1, H2O is a liquid as it has not boiled yet, it's not over 100 degrees, so that is 0. Although there's 2 moles, it is not a gas, so you can either write 0 or ignore it. So the next stage is putting the numbers in from the question. So you'll see it says you want to know what volume of CO2 when given a volume of oxygen. Now previously you may use calculating number of moles and then do a ratio to figure out volume, but this is much easier than that. So if you take that 100 and that's C of your O2, put that underneath your O2, and you in the ratio decide how much CO2 you would make. So if you complete the ratio, if it's 2 to 1 comparing O2 to CO2, it would be 100 to 50. And that there is your final answer. You would make 50 cubic centimetres of CO2. There is no need to do it for CH4. You could if that helps you fill in the blanks, but it is not part of the answer. Excess ratio. So in this one, you have an equation again. I've split this into 3 parts as there is further questions you could be asked here. So we have 30 cubic centimetres of methane, methane's there, burned completely in 100 cubic centimetres of oxygen at 25 degrees Celsius. So this time you have 2 numbers, so it's not as simple as just doing what you did in the simple ratio. So if you take what's there, I am just going to rewrite my equation. And the question says, what is the volume and composition of the gas at the end of the experiment? So you would need to work out how much gas you will make, so CO2, but you may also have some gas left over from your reactants. You'll need to consider that. So what you should do is this time get your ratios again. So 1 to 2, 1, and water 0 because it's a liquid as it is 25 degrees. So right here, H2O is a liquid until 100 degrees. So you do not include it until you are past 100 degrees. So that could be either 0 or just ignored. So in this case, we have 2 values, so methane 30, oxygen 100. So if you take them as 2 separate ratios, I tend to just number them 1 and 2. So if you take methane first and write its value in, so 30. So that came straight from the question. Compare the values. Ignore the 100 value just now, we'll come back to that. But compare the values and fill in the blanks. So we would have 30, it's 1 to 2, so 30 to 60. And to 1, it's just going to be the same number, 30. We have 0, so we either write 0 or leave it blank. The next one is taking the 100 value. So it was 100 of oxygen. So So write it underneath oxygen. Highlight it so you know that's the number you had in the question. Then again, ignore this line, just compare to that ratio. We have 100 and it's 2 to 1, so 100 gives you 50 here and 50 here, because it's 2 to 1, 100 gives you 50. Again, leave water 0. So at this stage, you now need to decide, well, which line is possible, because in one you make 30 CO2, but in another you make 50. You can't do both, only one will be possible. So looking at the highlighted values, these are the numbers I had. That's how much I had available to start with. So if I have 30 of CH4, I can't do the second line because I need 50 of it. In the oxygen section, I had 100 from the question. In the first line, I need 60, which I do have. I'll have some left over, but I do have enough to use 60. So in both scenarios, for oxygen, you could do either line. For CH4, you can only do the top line because you don't have enough to do the 50. So you would need a sentence, something like, only option 1 is possible. Won't be the case in every situation. It could be option 2. You would need to decide based on the numbers. So only option 1 is possible. So 30 cubic centimetres of CO2 is produced. Now that's not everything, because it's the volume and composition of the gas at the end. Now yes, you've produced 30 CO2, however you're going to have some left of one of the ones you started with. Now if I had 30 CH4 and I used it, then it's not going to be that one. I'm using 60 O2 and I had 100, so I will have 40 left over. So I'd also need to write that 40 cubic centimetres of oxygen left over. That is your excess. I'll also put in how we got that number. So 100 take away 60. So you would need a sentence pointing out the difference. You may be asked what's the total gas produced. In that case you would say 30 plus 40 is 70. If it wanted the composition, that is each gas separate. Part B, what is the total gas volume at the end of the experiment if it were repeated at 120 degrees Celsius? So we know that we definitely used 30, made 30 and used had 40 left over. So there's definitely going to be 70. So I'll just write 30 plus 40 from this section here. But this time, if it's 120 degrees, water is now a gas. So if we go back to the equation and go back to option 1, now including water to be 2 moles here, that would mean that you would make 60 water, because 1 is 30, so 1 to 2 would make the water 60. So I'm adding 60 in because that's your water. So if you add that up, you should get a total of 130. Part C. How would your answer to part A change if the resulting gas mixture was shaken with sodium hydroxide? Now sodium hydroxide is an alkali, and alkalis can neutralise acids. In this particular equation, there is no obvious acid. You'd be looking for H+ ions, but going from National 5 knowledge, carbon dioxide dissolved in water is acidic. So the alkali would remove the CO2. So alkali removes CO2. So how would that affect your answer to part A? Well, if you go to part A, you said that you would produce 30 cubic centimetres of CO2. You then remove that, so you would decrease your answer to just be 40. So you would want to say decrease answer to 40 as CO2 removed by the sodium hydroxide.